morning to our students. Today we are going to learn the one of the identities of 8th class, that is a plus b of a minus b. The product of the two binomials which are a plus b and a minus b. Here we derive the identity, that is a plus b of a minus b. A of a minus b plus b of a minus b, which gives a square minus ab plus ab minus b square. So we remain with a square minus b square. Okay. Let me prove this through a geometrical figure. Suppose if I have a square of side a, whose side is a, its area is a square, obviously we know it. So I extend one side to b units, that is I add plus b to one of the sides, and the other side I decrease by minus b. Let me complete this with the new dimensions, that is the new measures of both the sides. Let me complete the square. Okay, this is the square of 10. Let me write all the measurements. It is also a, b, a, minus b, minus b. See, on the whole, in the new square formed we have four regions, out of which one is a square, already we solved, and this is a rectangle where the length is L and breadth is B, so area is equal to AB. And this is one more rectangle where the length is A and breadth is minus B, its area is minus AB. Okay, and here is a small square whose side is minus B into plus B, which is minus B square, its area. Let me compute the areas of all the figures. The area of this major one, a square, and the area of this minus AB, area of the third rectangle, that is plus AB, and the last square is minus B square. Okay, we remain with a square minus b square. Okay, so a plus b of a minus b is a square minus b square. It is a simple way of learning and deriving the identity through geometry. So what is the use of this a plus b of a minus b? How can I use this in our regular calculation? Based on the situation in your regular work in any chapter, we can apply this rule. Suppose, let's see how this identity helps us in various areas in our regular work. 1. Here we have a binomial 2x plus 3y of 2x minus 3y. So before applying any identity, you must have a vision. That is there any hidden identity? Is there any formula? Instead of rote method of multiplication, you have to think in a different way. Unless you open your mind, you cannot get any idea in your mind. So the mind is important, not the formula. Okay. Whenever I see this with my vision, not with these eyes. This eyes, I see only the question, not the idea behind the question. So to see the idea behind the question, you must have a vision. So through the vision, I observe this is in a plus b, whereas a minus b, since the first term of both the binomial is same and the second term of both the binomial is same. That is, it is in a plus b of a minus b. I concluded finally. So I write the same here, is in a plus b of a minus b, because I replaced a for 2x and b for 3y in my mind, not through eyes. So I decode what for a in our mind is 2x and b for 3y. So these are my values I substituted in my mind for the places of a and b. Now let me write the full identity to get the product of these two given binomials. So the Identity I use here is a plus b of a minus b, which is a square minus b square. We proved already geometrically, is equal to a. What I have in my mind, I mentioned here, that is 2x. 2x. I said already use brackets whenever you substitute a and b values. Minus b is equal to 3y. 3y whole square. Let's complete. It is 4x square minus 9y square. Okay. Without multiplying, without expansion, without cancelling, without, just by recalling or recollecting the identity we learned with the vision, we come to the product, which is a binomial 4x square minus 9y square. Very simple. So you may think it is the only use of the identity only to get the product of binomials. No, there are many uses out of these binomials. Let's see one more example. I multiply two numbers. This is example 2. I want the product of 103 and 97. Both are different numbers. But the common value for both the numbers is both are close to 100. That's the nearest 100 is for both the numbers is 100. So I write the given first number 103 as 100 plus 3 and the rest as 100 minus 3. Now it is in a plus b of a minus b. Okay. So is in a plus b of a minus b. Now we know what is a for in my mind, that is 100, and b for 3. Clear? Very good. 3. Okay. Now as per the identity, which is a plus b of a minus b, the product of the two numbers is a square minus b square. So we did not multiply these two in a rote method as a regular thing. So a for 100, that is 100 square minus 3 square, which is 10,000 minus 9, which is 9,991. See how simple, without any struggle, without any error, without using tables much, we got the product of a 3-digit number and 2-digit number based by identifying the hidden identity inside the question. So this vision is very, very important. So one should develop this vision. What the idea behind giving this question? Is there any identity? Instead of looking with your eyes, through your vision, when you see the question, you see everything easy. That's the main problem. Most of the students read the question, they don't see the idea behind the question. If you see behind the question, you get many, many, many wonderful ideas and tricks. Keep watching. I add many more questions by using the identity, the same a plus b of a minus b in our next videos. Thank you for watching.